Solving rational expressions. Number one, we have 9 over z plus 1 over 2 is equal to 8 over z. So we have solved equations that contain fractions before. If you go back to the first first 2 weeks of class, we talked about how to solve linear equations that contain fractions, and what we had to do was find the LCD and multiply the LCD to every term, because we didn't want the body of our work to have fractions in it. So if we don't want the body of our work to have fractions, we found the LCD. What makes this section different is that now our denominators have variables in it. And because they have variables, um, we it's a rational expression, number one. And number two, what we're going to have to do is we're going to have to set some rules to this equation, meaning what number cannot be placed in the denominator, because it'll make that denominator undefined. And we're going to find that what's called restriction. We can have any other number in that denominator except what? But as far as us solving and finding the LCD, this being a fractional equation, that is not new to us. So what we're going to do, first of all, is find the LCD. So we have a z and we have a 2. Well, there's nothing in common, but each circle is different. Therefore, our LCD is 2z. So we want to, and we're going to talk about this, what happens with the restrictions and all of that, and what takes place. But we want to set a restriction. And then what you're going to tell me is what number or numbers cannot be placed in that denominator, because if we do so, then that denominator will be, it'll be 0, and it'll make that expression or that fraction undefined. So we're going to set the LCD equal to 0 to find this restriction. So 2z equals to 0. To solve for z, we divide by 2. We have z is equal to 0. Therefore, what this is saying here, we can have any other number in that denominator except 0. So what we're going to do now is solve the equation. We have this, and we're going to talk about what happens if you set a restriction and then your answer is the restriction, but the restriction says it cannot be. I'll show you how to write that solution and what it means. So let's solve. We're going to take, first of all, let's identify the terms on each side, and then we're going to take the LCD and we're going to multiply it to every term. And we're going to reduce each term. So for the first term, we want that denominator of z to divide into the LCD, and it does. And what we're left with is 2 times 9, we have 18, plus, let's look at the middle term. The 2's are going to divide out. We're left with z equals 2. And then the last term, the z's divide out. We have 2 times 8. That gives us 16. This is the same equation, but without it being in fraction form. So now we can solve. And we solve this equation in which we have 18 plus z is equal to 16. We're going to subtract 18 to both sides. And we have z is equal to -2. So our solution is not the restriction. So right now we're definitely okay with this answer. But we do not want to have 0 as the solution, because we already have the restriction to that. But our solution is z is equal to -2. Example 2. We have here 3 over x minus 3 is equal to 18 all over x squared minus 9. Now we factor that x squared minus 9, and then that will give us, so we can find the LCD, x plus 3 times x minus 3. So the first circle we're going to have that represent as x minus 3. The second circle, x plus 3 times x minus 3. What's the same? X minus 3. So the first circle is taken care of. The second circle, what would be different? X plus 3. So our LCD is x minus 3 times x plus 3. That's our LCD in which we're going to multiply on both sides. But we want to state the restriction. What cannot happen in that denominator? Because what number cannot be placed here in this denominator? Because if we place it here, it will make the denominator 0. In turn, it will be undefined. So that's what we want to set. So we're going to take our LCD, which is x minus 3x plus 3, set it equal to 0, and then set each factor equal to 0. So x minus 3 is equal to 0, therefore x is 3. X plus 3 is equal to 0, therefore x is equal to negative 3. Therefore, x cannot be, this means does not equal to, it cannot be a positive 3, nor can it be a negative 3. So that is our restriction. So we do not want to have, when we solve this equation, we don't want to have these as 3 and negative 3 as a solution. But if we do, I'll show you what we have to do here. So we're going to take the LCD, multiply it to each term, and then we're going to reduce. So here we go. The x minus 3 that's in the denominator, those cancel, and it divides into the x minus 3. What we're left with on the left-hand side, we have 3 times x plus 3 equals 2. Look on the right-hand side. X plus 3's divide out, the x minus 3's divide out, and we're left with 18. This is the same equation, but without the fractions. Let's solve. We're going to distribute the 3. We have 3x plus 9 is equal to 18. Subtract 9 to both sides. We have 3x is equal to 9. Divide by 3. And we have x is equal to 3. Okay, so we have a solution of 3, but we have a restriction of 3. We have a problem now. So because we said that our denominator cannot be 3, nor can it be negative 3. So in the event that this happens, this is what we call an extraneous solution. We have a solution that's not going to work out. So what we will write as our answer, because this cannot be our solution, we would say that this example 2 does not have a solution. We would say no solution, or you can use the symbol. And here's the symbol for no solution.